Right, so in this video, I want to look at writing oxidation numbers. And so we'll do the first one of these very slowly and, kind of like a way that we can always determine the oxidation number of a species in a compound. And there's also a little mistake that you need to be aware of. So this just needs to be H2SO4. Is a H2SO4 2 minus doesn't exist. But anyway, so let's get into it. So for A, we have NF3. So the species that we know something about is F. F will have an oxidation number F, so let's maybe, so the oxidation number of F is equal to -1. The species has an overall charge of 0 because it's a compound, it doesn't have a charge. And hence, we can then determine the oxidation number of nitrogen from the fact that the oxidation number of nitrogen plus 3 times the oxidation number of fluorine is going to be equal to 0. So we have oxidation number of nitrogen plus 3 minus 1 equals 0. So hence the oxidation number of nitrogen equals plus 3. Okay, so that's essentially how we'll go about for each of them. So for B, we have carbon dioxide. And which one do we always know something about? In this case, we know something about oxygen. So the oxidation number of oxygen is always -2, or except in peroxides, but we'll look at one of these exceptions. And therefore, it means that the oxidation number of carbon plus 2 times the oxidation number of oxygen needs to be equal to 0 because, again, this is a molecular compound. It does not have a charge. So then it means that this carbon, the oxidation number of carbon, must be equal to plus 4 because you're going to put a -2 there. For C, we have FeO3. So again, the overall species is not charged. It has a 0 charge. So that means the oxidation number of Fe, so 2 times that, plus 3 times the oxidation number of oxygen needs to be 0. The oxidation number of oxygen is -2. So it means sort of 2x plus 3 times -2 is then going to give us the oxidation number of Fe is equal to plus 3. All right, then we can also say oxidation number of oxygen is equal to -2. H2SO4. So the oxidation number of hydrogen is always +1. The oxidation number of oxygen is always -2, except in peroxides. And so it means that 2 times the oxidation number of hydrogen plus the oxidation number of sulfur plus 4 times the oxidation number of oxygen needs to be 0. So this is also a molecular compound. Its charge is 0. That means we have +2 plus ONS plus 4 times -2 is 0. That means the oxidation number of sulfur is then equal to 2 minus 8 is -6 is then going to be equal to +6. And you can write this in any way that you want. You just need to conclude to it. So you can call it X and Y and Z. It's another method that I use in the other one. So you can call it that as long as you at some point say, therefore, the oxidation number for hydrogen is this, oxidation number for oxygen is this, oxidation number for sulfur is this. So in principle, just answer the question, actually. And then you can do it in any way that you would like. Important species here is H2O2. So this is peroxide. And this means we need to slightly alter our thinking, because normally we would have said, well, okay, molecular species, zero charge. Then you would want to say, okay, hydrogen is always +1 and oxygen is always -2. But if you do that, you realize that the species charge cannot be zero. One of these needs to budge, and the one that budges is oxygen. So 2 times the oxidation number of hydrogen plus 2 times the oxidation number of oxygen needs to be zero. And hydrogen cannot have a charge other than +1. So it means we have here 2 times +1 plus 2 times the oxidation number of oxygen, giving us 0. So that means in this case, the oxidation number of oxygen is equal to -1. So, I mean, you can quickly solve that. Take the -2, so it becomes 2 O equals -2. So then oxidation number of oxygen must be -1. And you see this in all, what do you call it, peroxides. So these kinds of things where oxygen is just with hydrogen. It has this special oxidation number. And these species are actually quite unstable. So that's that's an interesting exception to the rule. And you have your rules, so you know what is an exception. But now you see it, and why it has to be an exception to that rule. Okay, thank you for watching.